Hey everyone, welcome to Elite Code Weekly Contest 281. Hopefully this contest goes well. I've done well in a lot of contests recently, and that probably means I've jinxed myself and I'm not going to do well this time. This contest probably also attracts a lot of high-rated people because of the prizes. So I think this will be quite tough. And already we can see that with a sponsored contest, nothing loads because why would it? Just less than equal to 1. Some int j for j minus 2 and 14. 2 14. Alright, AC. Another linked list. Alright. That should be 411 and 134. Elicode's probably not going to run. For 11 and 134. Using the characters such that no letter appears. AC. Let me read this one first. Oh, I don't like this question. Okay, I'm not quite sure how to do that one yet. So what I want to do, largest string, no more repeat limit times in a row. I don't have to use all characters. Oh, I don't have to use all characters, okay. In that case. I'm not sure if I trust Python, so I'm actually going to go with C++. String as therefore we can I equals to 25. While if I is not equal to Beth, or none is not equal to S, otherwise and then the rest of that. Otherwise, if j is greater than or equal to 0, I'll do stuff. Otherwise, I need to break. Right. Something like that. Alright, that got AC. Now there's only this question, which I do not like. Number of pairs. I feel like I could Google this question, but I don't really want to do that, since the numbers are only up to 10 to the 5. What's the max? What's this? 1,000 is at 84. Probably this one has up to 128 factors. So each number has at most 128 factors, which means that if I do 128 by 10 to the 5, that has a chance, it has a very slim chance, which is probably not good enough. Right, I'm just going to try. Next int pre-calc. $100,005 if pre-calc 2.empty. That means I haven't done stuff yet. So for int, okay. Int z equals to k divided by the GC. Okay, so the thing is, I could do this, but that means that it's 10 to the 5 times the number of 10 cases, which could be big. But I'll just have to risk it, I guess. Yes, to GCD. Recalc Z num I plus plus check marks 70. Oh, that actually got AC. Okay. I'm a bit surprised. So I'm going to resubmit something just in case it fails later on. I'm going to put it there. And then let's see equals. Right, I'm just going to do this for safety, just in case. This has a good chance of. This has a decent chance of TLE, but it's been 11 minutes. Let's see how I've gone. So the leaderboard is not updating, so I actually have no idea how I did. All I can see is that I did pretty well on questions 1 and 2. Anyway, I'm just going to go through the answers. Okay, I think this contest actually has a good, decent chance of TLEing afterwards. So after I record this, I'm probably going to go back and write some safe solutions in case some of my solutions get rejudged. Anyway, for this question, this is a brute force. I'm looping over all numbers which are at most nums. S is going to be the digit sum. If the digit sum is even, then I'll add 1 to my answer. The way I find the digit sum is I'm converting it to a string, iterating over each digit in that string and converting that digit back to an integer, and then taking the sum of all those digits. You don't have to use strings. You could just do this with a loop. For example, we could just do it like this. This would just continue while j is non-empty. We're going to get the units digit of j, and then we're going to remove the units digit. So that would also work, for example, without strings. This question, like a lot of linked list questions, you're supposed to do it in O1 memory, but no one can really be bothered. I'm assuming, okay, my solution is just convert the elements in the linked list into a list. And then for each element, and I'm going to keep a running total of the current sum of like the block which we're in. The block is like the group of nodes between zeros, and I'm going to keep track of this as I iterate over the prefixes. I'm going to keep track of the sum of the current block I'm in. If the element I'm currently at is non-zero, then I'm going to increment my my counter for the sum of the block. If it's 0, then I'll add that block to my answer, and then once I have my answer list, I just convert that list back into a linked list. So this is kind of a bad way to do it. I think because this is O(n) space, so with linked list questions, you're usually supposed to do them with O1 space. So I think what you can do is you can just iterate through this thing, and you can yeah, I'm really bad at linked list questions, if I'm being honest. I'm assuming the intended is like, you know what, let's because there's zeros, what I can do is just when I get to a node, I can just increment like the previous node by the current sum, and if it's a 0, then I won't do that. Basically, like you iterate through the linked list. If I get to a non-zero node, then I'm going to increment my previous node by the current value, and then I'll move on to the next node. And if I'm at a 0, then I don't do anything, I just move on. And that's because each of these nodes will now build upon like the 0, kind of. And then in the end, I just return the linked list without the head. and without the tail as well. Construct string without repeat limit is just greedily, you can greedily keep taking the longest, greedily taking the largest letter that you can, as long as you can. So here I'm building a frequency table where here AR is the frequency of the ith letter, where like 0 represents A, 1 represents B, so on. I'm just going to loop. What I'm trying to find is, first I'm trying to find the largest character that I have left. And what to also check if I'm allowed to take that character, I need to store the previous character that I took, if I did take one, and how many times I took that last character in a row. And that's because if the current character is equal to the previous character, and the number of times I've taken that previous character is already repeats limit, then I can't take that character. So if I can't take that character, what I'm essentially doing is I'm looking for the next largest character, and if such next largest character exists, then I'm going to take that character. And otherwise, if my current character is not equal to the previous one, or I haven't hit repeats limit yet, then I'm going to take the current character. This bit is just updating Beth and nums. If the current character is equal to the previous character, then I'm going to increase the frequency of that character. Num being the number of times I've taken the last character in a row. Is kind of like a streak. And then if it's a different character, then I'm going to reset the streak. And okay, this complexity is O n times 26, because 26 was alphabet size. I'm not sure if you're supposed to do ON, but it worked. Finally, there's this question. Basically, I'm not sure if this one is supposed to pass, but anyway, let's say that my current value is, I'm just going to pick k equals to 20, and let's say my current node is k equals 6. So my current j is 6. Nums j is 6. Now, what possible nums I could I have such that 6 times x is a multiple of k? So I need to choose a nums I such that 6 times nums I is a multiple of k. Well, multiple of 20 in this case. Well, in this case, we can decompose 6 into its factors, which is 2 times 3. We can see that since 3 and 20 have a GCD of 1, or greatest common divisor, then the 3 is actually totally irrelevant. So it's the 3 part of the 6 is not going to affect our answer. So what I'm really asking is 2 times nums I has to be a multiple of 20. And you can basically see that nums I must be a multiple of 20 divided by 2, which happens to be 10. And this always works. If this happened to be a 4, then I need nums I to be a multiple of 5, and so on. So that's basically what I'm doing. When I get to my current answer, first I'm taking the GCD of k with I, and that basically converts the 6 to a 2. It gets rid of the unnecessary prime factors that don't appear in k. And then nums I must therefore be a multiple of k divided by that number. I.e., when I'm at my current I, so this I is really actually nums j in terms of this statement. When I'm at this current element, now all I need to find is how many elements have I looked at previously which are a multiple of z. So I've called it z here. So all I need to know is the number of elements I've seen so far that are a multiple of z, and that's num. So num x will store number of factors of x. So how do we do this? Well, once we've processed a node, we simply for each of its factors, we're just going to increase nums of that factor. It's pretty simple. I make a slight optimization by taking z with the GCD of k. So this is a different z. instead of just adding all the factors of I, I'm taking all the factors of, I realized this is actually bad variable name duplication. It should probably be something more like this. I hope this is not undefined behavior. I'm just going to submit that. Yeah, so instead of just adding the factors of I into the number of factors of my frequency table, I'm simply taking the GCD of that with k, because I only care about the factors of I, which are also factors, which also have like some factors in common with k. And yeah, that's just slight constant optimization. And this is actually the more complicated code. This part is irrelevant. This is just resetting nums to be 0 again, because I need all of the elements of nums to be 0. But so in my original submission, I did something like this, which means that it's actually going to reset nums for every test case. So if there's t test cases, this is OT times 1 times 10 to the 5. So if t is big, this could actually be bad. But I'm just hoping that t isn't big. So this part isn't strictly necessary. I'm just going to rechange it to be that. And then all that's left is I need to be able to get the factors of a number quickly. And I'm just doing this by pre-calculating for each factor, for each multiple of that factor, I'm going to add that factor into the multiples set of factors. So pre-calc x here is the set of factors of x. The reason why this works is when I is 1, this will run 10 to the 5 times. When I is 2, this will run 10 to the 5 divided by 2 times. So in total, this is going to run 10 to the 5 plus 10 to the 5 divided by 2 plus 10 to the 5 divided by 3, and so on times. And that, if you take the 10 to the 5 factor out, that's 10 to the 5 times 1 plus 1 over 2 plus 1 over 3 plus so on. And this is the harmonic sum, and it's well known that this is O of log n. So in total, the time is O 10 to the 5 times log 10 to the 5, which is good enough. The last thing to note why the solution works, I think I searched it up. I'm not sure if this is technically true, but roughly, I think the maximum number of factors of a number under 10 to the 5, I thought it was 128 from the Wikipedia page, but I'm not entirely sure. So 10 to the 5 times 128, that's about 10 to the 7, so it's good enough. Okay, it's time to check how I did. Wow. So if nothing changes and everything is the same, that means that's an Apple HomePod Mini, but I would not trust the leaderboard being updated yet. I'm hoping I'm just going to get at least one of these prizes, but so far it looks pretty good. Anyway, that's all I have for you today. I'll see you next time, and thanks for watching.